All right, good morning. Happy Tuesday. Glad you're able to make it to class. Couple of announcements. First of all, I am trying to teach you more than math here. Trying to teach you some life skills. So one of the things that I don't want you to be late. And the reason why is because that's good practice for real life. If you're late to your job, some jobs have a time clock. And when you punch in, if you're a minute late, you could lose your job. I'm not kidding about this. Also, you cannot be just absent arbitrarily. So attendance is important. What's happening right now is some people are calling the attendance office, and the district and the school, they're being pretty lax about attendance. So like if you're in class for 2 seconds, they'll mark you present. And I'm telling you, they're notifying me, and I'm saying, do whatever you want. You know, if the students want me to mark them here present and they're not here, whatever. You know, there's so much I can't control that it's up to you. I mean, you're making decisions about your future. You're making decisions about what you're learning in this class. So if you want to be late, but you're not going to be able to do that in real life. I'm just letting you know. Like I said, I'm trying to teach you real life skills. Number 2, can't be absent at work. If you're absent at work, you can lose your job. So just letting you know. But like I said, the district and the school are not teaching students what real life really looks at, because we're being so lax about attendance. You know, we're saying, if a student's in class for 10 minutes, mark them present, but you're supposed to be in class for 80 minutes. So it's kind of like we're promoting students to fail in real life. And I'm not into that. I'm trying to set students up for life skills so you're not shocked in real life. So just to let you know, I am aware, you can be late, you can be absent or be in class for 5 minutes. And I'm telling the attendance office, if they want to be marked present, mark them present, it's like, whatever, there's nothing I can do about it. If I was the principal, if I was the superintendent, there would be penalties for being late. There would be penalties for being absent. But that's me, and I'm not running the school, so whatever. So I'm just letting you know, you want to play these games and be late, you want to play these games and be absent, go for it. Because I'm telling attendants, do whatever you want. I don't care. They don't want to show up in class. We're not teaching them life skills. We're teaching them things that are not going to happen in life, because you can't be late to work and you can't be absent from work. That's how you lose your job. So just letting you know, if you want to follow along with what I'm trying to teach you as far as life skills go, perfect. If you don't and you want to be on your own page and do whatever you want. All right. So we're going to have an exam on February 23rd, which is Tuesday, at 8 in the morning. It's going to be 2-6, 2-7, and 2-8. I am teaching 2-8 today. But before I get started, I just want to make sure that you don't have any questions on 2-6 or 2-7. So anybody want to ask me any questions on 2-6 or 2-7? I am teaching 2-8 today. I think your 2-7 is due tonight. So it's due at 11:59. In my opinion, you should already be done with it. I just make it 11:59 so that you have plenty of time, but you shouldn't be doing it up until 11:59. That's crazy. Okay, last call. Anybody want to ask me any questions about solving polynomial inequalities or solving, what was it, the rational inequalities? All right, today is kind of like a change of pace. We're looking at variation problems, and there's 4 objectives. We're going to look at direct variation, inverse variation, combined variation, and joint variation. And we're going to look at some real life problems. And they're actually, if you know which formula you're using, they're pretty easy. So if you get in the reading, if you see joint variation, you know to use that formula. If you see direct variation in the problem, use that. So you're looking for certain words. Make sure you take good notes. This is lesson 2-8. And this is modeling using variation. So don't write this down right now. Just, or you can write that down, but I'm gonna just say something here. So you don't need to write this down. I'm just gonna talk about something. Let me pin myself. All right. So this is a formula that shows the daily number of phone calls. You don't need to write this down because I'm just talking right now. This is the daily number of phone calls, C, and it increases as the population of these two cities. So this is one city and that's the second city population. Those populations in thousands increase and decreases as the distance between the cities increase. So someone wrote this formula and it can be used in this type of problem that I just read. So certain formulas occur so frequently that in applied situations that they are given special names. And these special names are what we're looking at with this, what I'm going to be doing today. So we're going to be looking, write this down, variation formulas. Show how one quantity changes in relation to other quantities. And these quantities can vary or change directly, inversely, and jointly. And when I teach these objectives, you're going to see me write direct variation, inverse variation, and joint variation. And I'm going to give you formulas for these. So all you have to do is in the reading, decide which one it is and use the formula. All right, so the first thing we're going to look at is direct variation. Can I erase this?
I think so, yes.
All right, so this first objective is called direct variation. And it says this: if a situation is described by an equation in the form y equals kx, k is a non-zero constant. So that means it's a number that can't be zero. So if k is a number that can't be zero, we say, when we read this, we say y varies directly as x. So that's how we read that. And you're going to put this in a box. So this is the first definition. So if a situation, a problem we do, is described by an equation of this form, k, which is going to be in all the formulas, is a non-zero constant. It's actually called the constant of variation. I'll write that up here in a minute. And we say y varies directly as x. So off to the side, k is called the constant of variation. And you're going to see it in all the formulas. So what I want you to do now is open your books to page 417, example 1. Page 417, example 1. And read with me, please. This is about blood. So this is about like medical stuff. Ready? The volume of blood, B, in a person's body varies directly. So that tells us it's this formula. See the words vary directly? That's this formula. As body weight W, a person who weighs 160 pounds has approximately 5 quarts of blood. Estimate the number of quarts of blood in a person who weighs 200 pounds. So see how they're giving us factual information. They're saying that a person who weighs 160 has 5 quarts of blood. That's a fact. And what they want us to find is the number of quarts in a person weighing 200. So here we go. So in step number 1, we know that we're using y varies directly as x. So write it down. Okay, what you're going to do is write your own formula. And we're going to say the blood is equal to k times the weight. So you're going to write an equation that makes sense in this problem so you don't get confused. And I'm going to write the steps over here in a minute. So the second thing we're going to do is we're going to use that formula to put in the information that we know. So we know that there's 5 quarts of blood in a person who weighs 160 pounds. So what we're going to do is we're going to find K using algebra. So we're going to divide both sides by 160. And by the way, when you work real life problems, you want to use a calculator. Here's the reason. If I go outside right now and start just measuring things, if I measure the height of my tree, it's not going to be 8 feet. It's going to be 8 5/7 feet. If I go and measure my pavers outside on the ground, it's not going to be 5 feet. It's going to be 5.5 feet. So the thing is that in real life, things are not exact. So since we're doing real life problems, we're going to want to use a calculator with these exercises. Okay, here we go. So on your calculator, what's 5 divided by 160? So give me the decimal. What's 5 divided by 160?
Point 0.3125.
Thank you. 0.03125. Okay. So what we did so far We wrote our own formula and we found the constant of variation. So what we're going to do now is we're going to go back to the formula and put in the constant of variation, and we're going to solve our new problem. Now, our new problem says that we want to find the number of quarts of blood with a person who weighs 200 pounds. So you see how I use the given information to find the constant of variation, and now I'm going to find the quarts of blood in the guy that weighs 200 pounds. So get your calculator. What's what you just read me, what's that thing times 200?
6.25.
6.25. So now nobody's going to understand what you're doing. So you have to give a report to the doctor. So the doctor wants to know, hey, we want to know how many quarts this guy that's 200 pounds needs. So you're going to have to write a statement that makes sense to a human being. That's not going to make sense to anybody. So here's what we're going to say. We're going to say a person who weighs 200 pounds who weighs 200 lbs has approximately or about 6.25 quarts of blood. And now I'm going to write down what we did. Okay, the first thing we did is we wrote an equation that makes sense to the problem. Write an equation that fits the problem. The second thing we did is we used the given information to find K. Use the given info to find K. The third thing we did is we set up our new equation with K. And the fourth thing we did is we solved the equation. Solve for what they want. What they ask for. So I'll repeat this. We wrote our own equation to match the problem. We used the given info to find K. We put K in the equation, and then we solved for what they asked for. And what I did, you guys, this is called joint variation. Now, the other problems are all done the same way, with just different formulas. So now, this is also direct variation, but it's called direct variation with powers. So same thing, but it's with powers. Direct variation with powers. So here's what you're going to put in the box. Y varies directly. Y varies directly. As the nth power of x if there exists some non-zero constant K. Okay, so here's this formula for varying directly with powers. It's the same thing, but instead of that, you're just putting x to the nth power. And we say, when we read this, we say y is directly proportional to the nth power of x. So that's how we read it. We say y is directly proportional to the nth power of x. Put that in a box. And let's take a look at a problem on page 418, example 2. Okay, look on page 418, example 2. Read it with me, please. This is about a skydiver, okay? The distance s that a body falls from rest varies directly as the square of the time, t, of the fall. If skydivers fall 64 feet in 2 seconds, they're falling 64 feet in 2 seconds, how far will the skydiver fall in 4.5 seconds? All right, so look what I'm going to do here. In the reading, it talks about the square of time. So I know they're talking about varies directly as a power. So here it is. I know it's going to be this formula because square means a power. And I'm going to write my own formula now, which is the skydivers is equal to k times the time squared. So that's the formula according to the problem we're using. The second step is to put in the given information. So they're saying that the skydivers are falling 64 feet in what, 2 seconds? So I put it in the formula. And so watch what I do. I get 64 equals what, 4k? Solve for k using algebra. K is equal to 16. So now that I found the constant of variation, I'm going to go back to the formula, which is S is equal to 16t squared. So I put the k in. And now I'm going to find what they want. So now we want to know S, which is going to be 16 times time. They want 4.5 seconds. So remember, the order of operation says to use, please excuse my dear Aunt Sally. So what's 4.5 squared?
$20.25.
Thank you. And now, all we do is take 20.25 times 16. So what's 20.25 times 16?
324.
324, thank you. And like I said, this is not going to make sense to most people. You don't do math. So you're going to want to write a statement for the person. You're going to say, in 4.5 seconds, the skydivers will fall 324 feet. So in 4.5 seconds, the skydivers will fall 324 feet. Okay, now everything I've taught right now has to do with direct variation. So the first one you saw was direct variation, and I just got through showing direct variation with powers. So let's go to the second objective. The second objective is inverse variation. So this stuff is not hard. You're just using the correct formulas and simple algebra. So let's look at objective 2, inverse variation. Let's see how it looks different than direct variation. So let's see. If a situation is described by an equation of this form, y equals k divided by x. So instead of being multiplied to x, it's being divided by x. K is the constant of variation again. So k is a non-zero constant. So it's a constant that's not zero. We say y varies inversely as x. So that's how we say it. Y varies inversely as x. Put that in a box. And let's look on page 420. Example 3. This example has to do with science and an aerosol can. You know, like when you push an aerosol can, like spray paint, what's happening? So let's take a look at it. Page 420, example 3. When you use a spray can and press the valve at the top, you decrease the pressure of the gas in the can. This decrease of pressure causes the volume of the gas in the can to increase. So see how this is inversely? So in other words, as the pressure decreases in the gas, the volume increases. So there's a decrease and an increase. Because the gas needs more room than is provided in the can, it expands in the spray form through the small hole near the valve. In general, if the temperature is constant, the pressure P of gas in a container varies inversely. So that's how you know what formula to use. So varies inversely as the volume V of the container. The pressure of the gas sample in a container whose volume is 8 cubic inches is 12 pounds per square inch. If the sample expands to a volume of 22 cubic inches, what is the new pressure of gas? So I don't know. I don't understand a whole lot of what I read. I do get the gist of it, but I do know I'm using this formula. So I'm going to write it down. It's inverse variation. And now I'm going to write my own formula to match the problem. So it's going to be the pressure is equal to K over X. I'm sorry, K over V, the volume. So that's pressure is equal to, or the pressure varies inversely as the volume. So we're going to find K by putting in the given information. The pressure was 12 and the volume they gave us when the pressure is 12 is 8. So solve for K. Now you can either put 12 over 1 and cross multiply. I did not say cross cancel. I said cross multiply proportion, right? Or you can just multiply this side by 8. Multiply that side by 8 is 96. So in the third step, you're going to put the constant of variation into the formula. P equals 96 over V. And now we're going to use the information that they want. They want us to find the pressure when the volume is 22 cubic inches. So a couple things here. First of all, we can simplify this. 2 times what is 9, 2 times what is 16 over 11. So this would be 4 and 4/11, which is how we want to measure pounds. Usually we don't measure pounds by decimals. If you did write the decimal for this, we don't like writing pounds in decimal though. It would be, can you guys do that? Well, it's not important. Let's not do it and say we did. We want to write it, this one as a fraction. So we're going to say when the volume is 22 cubic inches, the pressure of the gas is 4 and 4/11 pounds per square inch. And you could write it better than that. You could write L pounds per square inch instead of writing it out. So pounds per square inch means pounds per square inch. So once again, this is inverse variation. Okay, anybody have any questions about what I'm doing over here? Okay, let's look at the third objective then, which is called combined variation.
Miss Birch, for step number 2, you just multiply 8 to both sides, right?
Well, you can either put this over 1 and cross multiply, but what I did is I multiplied both sides by 8. I'm just solving the equation.
Okay.
8 equals 96.
Okay, thank you.
So everything you see me doing, I'm using algebra. So I'm multiplying both sides by 8. But don't forget, when you set up a proportion, remember 2 fractions that are equal? You can cross multiply. So K times 1 is K and 12 times 8 is 96. So however you want to do it. Either set up a proportion and cross multiply or multiply both sides by 8. And I'll tell you, half the class is going to like doing it this way and half the class is going to like doing it this way. And it doesn't matter which way you do it. Now, on this one, we're looking on page 421, example 4. So I'm going to set up the problem for us. So I don't see this a lot. This is called combined variation, direct variation, and inverse variation. Occur at the same time. So I'm going to read this problem in a minute, but in this problem, let me write the page up. Maybe I'll read the problem first. This is a sales problem. It's on page 421, example 4. And I'll read it to you. It says, the owners of Rollerblades Plus determined that the monthly sales S of their skates vary directly as their advertising budget, A, and inversely. So see how it says directly and inversely? It matches combined variation. And inversely as the price of skates P. When 60,000 is spent on advertising and the price of the skates is $40, the monthly sales are 12,000 pairs of rollerblades. So let me set it up for you. So it says that the monthly sales vary directly as the advertising budget so this would be written as sales is equal to the constant of variation A, which is the advertising budget. So this is sales, advertising budget. And then it says that the monthly sales vary inversely as the price of the product. So this is written sales is equal to K divided by P, because it's the price varies inversely. So we're going to combine both of them. So we can combine these two variations. Variation equations into one combined. So watch how I'm going to do it. I'm going to write S is equal to, the K is on the top in both, so the K stays on the top, A stays on the top, and P stays on the bottom. So that's our combined equation by putting these two together. And now I'm going to work the problem. So that's our equation. And we know that the sales is 12,000. We're going to find K by putting in what we know, 60,000. And they said the price was $40 per pair. Now watch how I do this. I'm going to cancel, that's part of a product, so I'm going to cancel the trailing zeros. So I get 12,000 is equal to 6,000 K divided by 4, right? So can you do this on the calculator? What's 66,000 divided by 4?
$1,500.
1,500K, right? So now I'm going to solve it by dividing both sides by 1,500. Watch how I do this. I'm going to cancel the trailing zeros. And 15 times what is 120? And that's 8. So I found K. So remember what we do. We go back in and put K and solve the problem that they want. So we go into this, this would be S is equal to 8A divided by P. So I put the constant of variation in. And now we're going to find S when A is 70,000 and P still stays at 40. Watch how I do this. 8's part of a product, so I can cancel the 8 and the 40. So a 5 goes on the bottom. So what's 70,000 divided by 5? What's 70,000 divided by 5? I can cancel like that, right? It's part of a product.
It's 14,000.
That's correct. So now we write our statement that makes sense. We're going to say with a $70,000 advertising budget, and $40 price for the rollerblades, the company can expect to sell 14,000 pairs of rollerblades in a month. So we're talking about up from 12,000. Now, here's what a lot of people don't understand. You understand Nike has a math person working for them, right? They have a lot of math people. So when Nike makes the Air Force Ones, they don't say, oh, this is a cool shoe, everyone's going to buy it. They don't do that. Because they have to consider the leather, which I don't know if you noticed the Air Force Ones, but they're different than the court Nike. The court Nike is kind of like a rough leather, but those Air Force Ones have the smooth leather. So they have to consider the cost of the material. They have to consider how much they have to pay their employees. They have to consider the cost of the electricity they use for the machines. So there's a whole bunch of things that they have to consider. And after they consider all those things, they have to figure out what feasible region they need to stay in to make a profit. They don't sit around and guess, I guarantee you that. Companies that fail do that. They guess. So Nike, after they take all these equations and they take a look at this feasible region, as long as they stay inside the region, they're going to make a profit. Now, there's certain places in that region that they're going to make a maximum profit. And trust me, Nike stays within that region at that maximum profit. And if they go outside, they're going to lose money, and Nike doesn't do that. So there's math people that are considering all these different variables. How much is the cost of the material? How much do they have to pay their employees? How much do they have to pay for the machinery? How much do they have to pay for the electricity? So on and so forth. And they mathematically, they set this stuff up so that they stay within a region where they're going to make a profit. They don't sit around and guess. That's how a business goes bankrupt, is sitting around and hoping. All right, so the final one I'm going to do is objective 4, and it's joint variation. All right. Joint variation is a variation in which a variable varies directly as the product, which means multiply, of two or more other variables. So let's read that. Joint variation is a variation in which a variable varies directly as the product of two or more other variables. It looks like this. Y is equal to the constant of variation, and then X, Z are the other two variables. And this is read as Y varies jointly as X and Z. Put that in a box. And I'm just going to show you Newton's formula for gravitation. Before we do this next problem. Okay, so I'm going to show you Newton's formula for gravitation before I do this problem. This is what it looks like. It looks like F is equal to G times m sub 1, m sub 2 divided by d squared. Now I'm going to explain what all this means. F is the force of gravitation, or the gravitational force. G is the gravitational constant, like K. These M's are two different masses, which is weight. And this D is distance between the masses. So F is force, G is the gravitational constant, M are the masses or the weight, and D is distance. Now in this problem, we're going to use a formula like this one. So let's look at the problem. I'm going to erase this. This is the last problem, by the way. I'm on page 422, example 5. All right, here we go. The centrifugal force, C, of a body moving in a circle varies jointly. So there's how you know what formula you're using. With the radius of a circular path R and the body's mass M, and inversely with the square of the time. So that's another way you know that you're using joint variation. Square of the time T it takes to move about one full circle. A 6-gram body moving in a circle with radius 100 centimeters at a rate of 1 revolution in 2 seconds has a centrifugal force of 6,000 dynes. Now, I've never even heard of that word before, so I don't even know what a dyne is, but it's 6,000 dynes. It says, find the centrifugal force of an 18-gram body moving in a circle with a radius 100 centimeters at a rate of 1 revolution in 3 seconds. So here we go. So we're going to use this formula as our model, and we're going to say that the centrifugal force, which mass is the force, is equal to, instead of G, that's our constant of variation. And up here, we're going to have the radius times M over time squared. So we use that to write this. So now, for centrifugal force, we're going to put in our 6,000. We don't know what K is. This R is 100, and that M is 6 from the problem. And the time was what, 2? We got to square it. So if you read the problem, the 6,000 is the 6,000 dynes. The 2 is the 2 seconds. The 100 is the 100 centimeters, the radius. And 6 was the 6-gram body, the mass. So watch how I'm going to do this. Can I say 4 goes into 125 times? Can I cancel the 100 and the 4? Hello?
Yeah.
100 divided by 4 is 25 times 6. What's 25 times 6? $150?
Yeah, 150.
Divide both sides by 150, solve it algebraically. I'm going to cancel those zeros, and now I'm going to use my calculator. What's 600 divided by 15?
$40.
40? Yeah.
Yeah.
So now I know my K, so I'm going to go back to my formula. C is equal to K. And then the R and the M this time is going to be 118. Because the 100 stays the radius. 18 is now the 18-gram body, that's the mass. Divided by 3 squared. Because now instead of 2 seconds, they want 3 seconds. So look up here real quick. Isn't 18 divided by 9 2? Can I do that? 18 divided by 9 is 2? Yes or no?
Yes.
So wouldn't this just be 40 times 200? And wouldn't that be 8 with 3 zeros? Yeah.
Yes.
So can't we say the centrifugal force is 8,000 dynes. Whatever a dyne is, I have no idea. So the centrifugal force is 8,000 dynes. And this, what I just showed you, is called joint variation. And like I said, all I'm doing is depending on the problem, whether it varies directly, whether it varies inversely, or varies jointly. I'm using the correct formulas. And I'm finding the constant of variation K, right, by using the given information. Then I'm using what they want with K to get the new information. Now, pay attention. That's the lesson, but listen to this. I did not sign the odds. I signed 1 through 10 all, and then the word problems like we did in class, I did 21 through 34. And this is going to be due on the 22nd. So you're doing less than 10 problems per day. So one of the complaints of students are the teachers are giving us too much work. Yeah, if you wait to the last minute to do it, but you're doing less than 10 problems per day. That's not too much to ask. So I hope I'm making myself clear that you should be using your notes. You should be able to do less than 10 problems per day. And like I said, on Tuesday morning at 8 o'clock, the 23rd, 22nd, let's go back. Tonight, 2.7 is due. Next week on Monday, this assignment is due. And we're taking an exam at 8 o'clock in the morning on Tuesday morning. So Monday, the assignment's due. Tuesday morning at 8 o'clock, we're taking a test on 2, 6, 7, and 8. All right. So what I'd like you to do right now until 12:10 is you're going to go into your Math Wizard teams and try to do the first 2 or 3 problems. Okay. And these problems are on page 423. And they're not even word problems. You can just straight out set them up. Okay. So remember the odds are in the back of the book, but I want you to do at least 2 or 3 problems in your teams, and I'm going to be taking attendance. All right. All right. I hope you guys have a great day. Does anybody want to ask me any questions about anything? Okay. Well, make sure when you read the problem, you're looking for words like directly, inversely, jointly. That'll help you to know what formula to use. All right, I'll see you in your Math Wizard teams. We are not reporting back here. Class is over at 12:10. I'll see you in your teams.